Good morning. Welcome to SDSU. My name is Geer, and I'm a professor of biochemistry. I'm also the undergraduate advisor in the Department of Chemistry and Biochemistry. In this short presentation, I will give you an overview of our undergraduate program, the degrees that we offer, and the distinguishing features of our program. I might mention a few career opportunities. Here's the overview. Our program provides a strong background in theory and laboratory practices in all areas of chemistry, including analytical, inorganic, organic, and physical chemistry, chemical education, and biochemistry. In analytical chemistry, we investigate the composition of matter. In inorganic chemistry, we study and synthesize inorganic molecules, those that contain metals. In organic chemistry, we study and synthesize organic compounds, those that are composed mostly of carbon, hydrogen, and oxygen. Physical chemistry investigates the physical aspects of chemistry. In chemical education, we study how we can better teach chemistry, and biochemistry is the study of the chemistry of life. Our students have excellent success rates in getting into graduate school, and others find jobs in local industry. All our students carry out research projects that are supervised by faculty members. So you have an opportunity to work side by side with a professor. We provide fairly funded internship programs that provide financial support to qualified research students. We have 23 faculty members, 80 graduate students, and 400 undergraduate students. What degrees do we offer? First of all, we have a BS degree in chemistry that is ACS certified. ACS certified means it is approved by the American Chemical Society. We also offer a BS degree in chemistry with emphasis in biochemistry and a BS degree in chemical physics. You have a BA degree that leads to a teaching credential and an ACS certified and a non-ACS certified BA degree. Most of our students graduate with the BS degree in chemistry that is ACS certified or the BS degree in biochemistry. What are the main differences between the BS degree and the BA degree? Well, the BA degree requires 3 semesters of instruction in a foreign language. The BS degree does not have that requirement, and therefore you can learn more chemistry. How do we choose between the ACS certified degree in chemistry and the biochemistry degree? Well, that depends on your interests. Luckily, those programs are very, very similar during the first 3 years, and so you can easily switch as you learn more about them. The distinguishing features of our program are that you have to do many laboratory courses and that you have to do research. That is because the guiding principle in our department is that chemistry is a craft. You have to do it. And the more you do it, the better you get. Therefore, laboratory work is emphasized throughout the curriculum, much more so than in many other schools. For example, as a freshman, you will take general chemistry, Chem 200 and Chem 201. Both courses include 3 hours of lectures and 3 hours of lab work a week. As a sophomore, you're very likely to take Chem 232, organic chemistry, and Chem 251, analytical chemistry. The organic chemistry course includes 3 hours a week of lab work, and the analytical chemistry course includes 6 hours of lab work a week. As a junior, you're likely to take physical chemistry labs or second semester of organic chemistry lab. And seniors take inorganic chemistry lab, advanced analytical labs, or if you're a biochemistry student, you will take the biochemistry lab. All our students have to take at least 1 unit of senior project research, Chem 498. And 1 unit is 3 to 4 hours a week. If you like it, you can take up to 9 units of research for which you can get credits. Another feature is that all our upper division labs, those that have a catalog number over 400, are taught by faculty members, so you can learn directly from our professors. Research groups usually are small, 5 to 15 students, most of them undergraduate students. And so students get individual attention. You work side by side with professors and you can learn directly from them. That's good because these faculty members get to know you, and it allows them to write very nice reference letters when you apply for jobs or graduate schools. What do our students do after graduation? Well, about half of them go to graduate school. PhD programs in chemistry, biochemistry, biology, or even physics. Others go to professional graduate schools, like medical school, pharmacy school, or dental school. The other half find jobs in local industry. 3% of our students, believe it or not, go back to middle school or high school to teach chemistry or science. And 5% of our students go to other fields. San Diego is also known as Biotech Beach. That's because there are many large companies that have facilities in San Diego, and those facilities offer job opportunities. On the left-hand side, you see biotech and pharmaceutical companies, including Pfizer, Bayer, Vertex, and Illumina. On the right-hand side, you see some high-tech companies, and I'm sure you've heard of Qualcomm and General Atomics. And then there are also some companies that are involved in environmental chemical testing at the bottom. I want to end with some pictures of former students. On the left-hand side, you see a group of students that graduated a few years ago. All of them found their way to graduate schools and job opportunities in the local industry. On the right-hand side, you see an undergraduate student that is presenting her work as a poster at an undergraduate research symposium. That's all I want to share with you this afternoon or this morning, and I will be available for questioning through Zoom. Thank you for your attention.